This is a level 2 functional skills maths paper from Open Awards. It's split into two parts. In the first part, you can't use a calculator, but you can in the second part. This is the first part. Task 1. The table below shows the distances walked by J each day in a week. What was the total distance J walked over the whole week? Show your calculations and or workings out here. So we've got Monday, 1.5 miles, Tuesday, 3/4 of a mile, Wednesday, half a mile, Thursday, 1/3 of a mile, Friday, 1/3 of a mile again, and Saturday, 3/4, Sunday, 0 miles. So we'll need to add all of these fractions and mixed numbers together. We've got, as I said, 1.5, 3/4, half, third, quarter. So let's group together the ones that are similar to each other. So 1/3 and 1/3. That gives us 2/3. So now we can look at quarters. We've got 3/4 and 3/4. That gives us 6/4, which is also 1.5. I'll show you quickly here. So that makes 1.5. So we've also got another 1.5 here. So if we add 1.5 and 1.5, half and half makes a whole one. Then 2, 3. So that makes 3 in total. So we've taken that into account, and we've also taken into account the 3/4. So that makes 3, the ones that we've taken. So that is 3. We also have half a mile here. So that makes 3.5 so far. And the 2/3 that we added together. So 3.5 and 2/3. Let's just ignore the 3 because it's a whole number and we need to add the fractions first. We'll add the 3 at the end. So half and 2/3. We need to find a common denominator for both, which can be 6, which is 2 times 3 as well. So to get from 2 to 6, we've multiplied by. So we'll do the same to the top number. 1 times 3 gives us 3. To get from 3 to 6, we've multiplied by 2. So we'll do the same to the 2 there to give us 4. So adding these together gives us 7/6. Now before we add it to the 3, we need to convert it into a mixed number. So 7/6, that is 6, 6 and 1/6. So 6/6, that is a whole. So that is 1 and a 6th. Now we need to add the 3 before we forget. So 3 add 1 and 1/6. That gives us 4 and a 6th. Write your answer in this box. So 4 and a 6 was the final answer. Put these fractions in order of size, smallest to largest. Show your calculations and the workings out here. So we've got 4/3, 3/4, 3/8, 5/8 and 7/6. Now looking at them in detail, we can see that this is an improper fraction and this is an improper fraction. The rest of them are not. So this means that this will be the largest fractions because they are greater than 1. So we need to first focus on these other 3. Looking at them, we've got 3/4, 3/8 and 5/8. 3/8 and 5/8 we can easily compare. 3/8 is smaller than 5/8. Looking at 3/4, we can easily make this with the denominator of 8 by doubling. So we've doubled 4 to get 8, we'll double the 3 to get 6. So this is 6/8. So that is larger than 5/8. So if we put them in order, 3/8 would come first, and then 5/8, and then we've got 6/8, which is 3/4, the way it's given to us. So we've done these 3. Now we can focus on the 4/3 and 7/6. Now what we can do, since this has a denominator of 6, this is 3, so we can double the 4/3. Well, what I mean is double the numbers to keep the fraction the same. So double the 3 gives us 6, double the 4 gives us 8. So that is larger than 7/6. So we're going to put 7/6 next, and then 8/6, which in fact I should put 4/3. I'm going to rewrite them here. Calculate 273,696 divided by 24. Show your calculations and our workings out here. So we've got 273,696 divided by 24. So how many 24s would fit into 27? That would be just 1. We have 3 remaining because 27 take away 24 gives us 3. So now how many 24s fit into 33? And that would be 1 again. Now 33 take away 24. That gives us 9. So we have 9 remaining now. Now how many 24s into 96? So 24 and 24, that is 48. 96 is much larger than that. So if we try 48 and 48, that 8 and 8 is 16. 4 and 4 is 8 and the 1 is 9, so that is exactly 96. So that is 2 lots of 24 and 2 lots, that makes 4 lots of 24. So there is nothing remaining. Now we move into the 9. How many 24s fit into 9? That's 0. And that means we have 9 remaining. So now how many 24s into 96 again? And we said 4 earlier. And there is nothing remaining. So we'll put the answer here. 11,404. Calculate the surface area of a cube when the length of a side A is equal to 15 centimeters. Surface area is equal to 6 lots of a squared. Show your calculations and our workings out here. So we're talking about the surface area of a cube, which is going to look more or less like this. So side length is 15 centimeters. So this is 15, so this is 15 as well. And of course this is 15 as well. So surface area, we'll need to work out the area of one of the faces and then multiply it by 6. That's what this is telling us as well. So 6 lots of a squared. 6 lots of a squared. So a is 15. To work out 15 squared, we'll do 15 times 15. So 5 times 5 is 25. So we have 5 down and 2 carried over. 5 times 1 is 5 and the 2 is 7. So now we put the 0 down. 1 times 5 is 5. 1 times 1 is 1. So adding these now, 5 and 0 is 5, 7 and 5 is 12, so 2 down and 1 is carried over, 1 and 1 is 2. So that is 6 times 225. So 225 times 6. 6 times 5, that is 30, so 0 down and 3 carried over, 6 times 2, that is 12, and a 3, that is 15. So 5 down and 1 is carried over. 6 times 2 again is 12, and the 1 is 13. So 1,350. And that was centimeters. So this is going to be centimeters squared, or square centimeters. Simon is redesigning his garden. He has drawn his garden on the diagram below, where 1 square is equal to 1,500 millimeters. Using the grid, calculate the actual length of the garden in meters. Show your calculations and our workings out here. So we're only interested on the length of the garden. So here is the length, and that is 1, 2, 3, 4, 5, 6, 7.5 squares. 1 square is 1,500 millimeters. Now we need to give the answer in meters. So it's worth converting this into meters before we multiply it by 7.5. So 1,500 millimeters we can convert it into centimeters. So in 1 centimeter there are 10 millimeters. So if I divide 1,500 by 10, it just gives me 150, so knocking off a 0. So that is 150 centimeters. Now, in 1 meter, there are 100 centimeters. So that's like how many cents in a euro, or years in a century. So if I divide 150 by 100, that means moving the decimal point 2 places to the left to make the number smaller, so I get 1.5 meters. It also makes sense if 1 meter is 100 centimeters, 150 centimeters is going to be 1.5. So 1 square is 1.5 meters. What about 7.5 squares? You can go through the long multiplication of 1.5 by 7.5, or you could do it 1.5 add 1.5, so that gives 2 lots. And we're looking for 7.5, 7.5. So 2 lots is equal to 3. If you add another 2 lots to make it 4, so that is 3 and 3 gives us 6. So we have 4 lots. If we add another 2 lots to make it 6, then we get 9. If we add another lot, which is 1.5, to make it 7, we get 10.5. So now we've got 10.5. We need half now to add to that. So half of 1.5. What is half of 1.5? Think of what's half of £1.50 or £1.50. What is half of that? That is 0.75. So if I add that here, it should give me 7.5 lots. So that's a 0 if it has no digits there after the decimal point. So 0 and 5 is 5. 5 and 7, that is 12. So 2 down and 1 is carried over. 0 and 0 is 0, and the 1, that's 1. 1, add nothing to add, gives us 1. So 11.25. And what is that? The unit is meters. Simon is planning to build a patio in the garden. The patio will have 4 sides. He has drawn a sketch of the patio below. Sketch not drawn to scale. Calculate the area of the patio. Show your calculations and or workings out here. So this is in the shape of a trapezium. If you want to work out the area of the trapezium, that's absolutely fine. So practically that is adding this, which is 8.4, to 6.6, dividing that total by 2, and then multiplying the answer by 4. What I'm going to do is instead, I'm going to split this into 2 parts, into 2 shapes, into a rectangle and a triangle. So in terms of the rectangle, we know that the length is 6.6 and the width is 4. So I'm going to do 6.6 times 4 to get that area. Six times 4, or 4 times 6, that is 24. So 4 down and 2 carried over. 4 times 6 again is 24, and the 2 is 26. How many decimal places? First number has 1 decimal place. Second number is a whole number, that's a 4, so it has no decimal places. So in total the answer will have 1 decimal place. So going backwards, 26.4 is the area. And looking at the triangle now, do we know what the base is equal to? We need to work it out because we know this total length here, which is 8.4. So if I take away 6.6, that will give me the base. So 8.4, take away 6.6. We've got to borrow 1 from the 8 to make it 7, so this becomes 14. 14 take away 6 gives us 8. 7 take away 6 gives us 1, so 1.8. That's the base of the triangle, and the height is 4, because these two lengths will be the same. So 1.8 times 4, 4 times 8 is 32, so 2 down and 3 is carried over. 4 times 1 is 4, and the 3, that is 7. Now we have one decimal place in the first number, but we don't have any in the second number, which is a 4, because it's a whole number. So we're going to give the answer one decimal place. So this is 7.2. So we know that area of a triangle is base times height divided by 2. So I'm going to have to halve 7.2. How many 2's fit into 7? That is 3 of them. And we have 1 remaining. Now we've got a decimal point here, which we're going to need to transfer to the answer. How many 2's into 12? That is 6. So 3.6. So we've got the area for the triangle as well. So adding that to 26.4, 4 and 6 is 10, so 0 down and 1 carried over. 6 and 3 is 9, and the 1, that is 10, so 0 down and 1 carried over. 2 and 1 is 3. So 30 square meters is the answer. For the foundation of the patio, Simon will use a dry mixture of sand and cement. He will need 20 kilograms of mixture for each square meter of patio. To make the mixture, he needs to mix sand and cement in the ratio of 5:1. Calculate how many 25 kilogram bags of cement he will need. Show your calculations and/or workings out here. So he needs 20 kilograms of mixture for each square meter of patio. And we worked out the area of the patio in the previous question, and that was 30 square meters. So 20 kilograms for each of these. That means we need to multiply 30 by 20 to work out how many kilograms of mixture he needs in total. So 0 times 0, that is 0. 0 times 3 is 0. Moving down, 2 times 0 is 0. 2 times 3 is 6. So that is 600 kilograms of mixture needed in total. And we've got the ratio of sand and cement. So that is 5:1. And this means 6 units in total. We need 600. Okay, so to get from 6 to 600, we have multiplied by 100. So we'll do the same on the other side. So 5 times 100 is 500. 1 times 100 is 100. What are we interested in is the cement, and that is 100 kilograms of cement that are needed. Question is, how many 25 kilogram bags? So as you know, 4 lots of 25 make 100, so 4 bags are needed. And this is the end of the first part.